3, 4 dividing rational numbers. Okay, so what's a reciprocal? Okay, it's also known as the multiplicative inverse. Now today and from now on, they're not going to use reciprocal. It's kind of an elementary word. They're going to use the word multiplicative inverse. So reciprocal, and I'll show you what it is the same thing as a multiplicative inverse. So in some of your directions, it's going to say, find the multiplicative inverse. It's not going to say reciprocal, but it means reciprocal. They're the same thing, okay? Now, what is it? If I give you 3/4, what would the reciprocal be, or, aka, multiplicative inverse, be, Ella? 4/3. Remember, it's just flipping the fraction around. We only use this for division. We don't use it for multiplication. We only use it for division. Let's say I ask you, let's say it's a whole number 6. How can we make 6 a fraction? Put a 1 under it, right? What's the multiplicative inverse going to be here, Haley? 1/6. Okay. The first, how many problems of your homework today says, find the multiplicative inverse. Yeah, right? All right, I know how to do that. Okay, let's do a little more practice. Let's go to, what if we have a mixed number? How do we find the multiplicative inverse of this, Kira? Yep, first thing we're going to do, we're going to make it an improper fraction. You're right. So this would be 19/3. Does everybody remember how to find improper fraction again? I feel like I've been talking about this forever, like 7th grade. 7th grade is in fractions too, so I cannot think of who I've talked about this and who I haven't, because we've been talking about fractions for the last 3 weeks. Okay, then you need to flip it around. So first you find improper fraction, then you flip. All right? So what about this one? Tell me what the improper fraction is of this. What's the improper fraction here? Somebody, anybody, Desi. Oh, okay, -7/2. That's all right. Negative just stays along for the ride. Doesn't change anything. Then I got to still flip it. Negative still stays along for the ride. Flip it around. I want to remind you one more time. I have a whole number. What's my reciprocal of the whole number here? Bella? Yep, put a 1 under it, then what? 1/7. Yep. So don't be afraid to put a 1 under the whole number, then flip it around. Any questions on the multiplicative inverse? I feel like this is something you've done since you were itty bitty, hopefully. Probably about as tall as you are now, some of you. Any questions? All right. Let's go to actually dividing now. Let's go to actually dividing now. Does anybody remember when we use the multiplicative inverse, aka reciprocal, when we're dividing, Alex? The second one. Remember we talked about keep, change, flip? We talked about that a little bit last year. So, or I think Mrs. Schneider talked to you a lot about it too. You're going to keep the first one, change this, flip this. Do you ever flip the first fraction? Never. This will happen today. Mark my words. It already happened in my other class. I even warned them about it. Somebody will flip both. Somebody will flip the first and not the second. It happens all the time. All the time. So K, keep. What are we going to change this to? Yep. What are we going to change this to then? It's going to look like this, right? Now multiply like normal. Reduce. You can reduce, but it has to be done after you do the flipping. Okay, you can't reduce up here. It's got to be done after you're done flipping. So can I reduce up here? Yeah. What can I reduce? Anybody know? What can I reduce? Alex? 9 and 12 by 3. 3 goes into 9 3 times. 3 goes into 12 4 times. Multiply across. 4. 3 times 5, 15. Done. How does that work? How would 9 go into 12? Oh, so you're talking about reducing now, and I'm confused by what everybody's talking about. What? Should I start again? Let me start again. Thanks, guys. Thanks. Sometimes I don't know what's being asked. You guys took care of it for me. Okay. Yeah, so find something that goes into 9 and 12, right? 3 goes into both. So how many times is 3 going to 9? 3 times, and then you're done with your 9. Remember, you're done with your 12 and your 9. You're using those other ones now. Okay. How does it work? There's probably a really long explanation that I could figure out for you and draw. I'm sure there's a picture I could draw for you, but I'm not going to do that today. To multiplying all of a sudden. It is. It's weird, isn't it? Now I need to look it up. Thank you. Now I will do that today. That's my homework. Okay? All right. Let's try another one. Now, if you have a whole number, what can you put under that whole number? A 1. Do it. Do it. Then do your keep, change, and your flip. Negative rules still go along. So if one's negative and one's positive, the answer is going to be negative. Negative rules still stand regardless if it's a fraction or not. We talked about that yesterday a little bit. And I don't think this can be reduced, can it? It's like negative 3 over 56. We're going to call that good. Yep. How are we doing? So far, so good? Easy enough to remember? Do we ever flip the first one? No. What do you flip? Just the second, all the time, all the time. Let's go to some that have mixed numbers. First thing you're going to do is what? Change all to improper fraction. Every single one of them. So this would be 12, 13, 14 over 3. Keep your negative, don't forget it. Divided by, and sometimes you guys, people get confused if they try to do improper fraction and the flipping stuff at the same time. So a lot of times it's easier just to do your improper fraction first and then do your keep, change, flip. This would be 27, 28 over 9. And then go back and change your stuff. So sometimes I find that a lot, people, if they try to combine two steps, they either forget to flip something or they didn't even make their improper fraction right in the first place. So if you just do it in your little steps, and this can be reduced by a lot, like a lot. Let's see. Wait, I'm missing a mark. There it is. This can reduce, goes in once, goes in 3 times, goes in once, goes in twice, I believe. Did you catch that, Kira? Do I need to go back? Did you see how I reduced? Just want to make sure you got that before I move on. Huh? Did you get this? Hold on. Let's go back. Sorry. I did it too fast. What's the matter? So, oh, so you took 7 out right away. You can do that, or you could take 14 right away out of both. If you just take 7, you're going to have reducing to do at the end, too. Twice. So, yep, goes in once, goes in 2 times. Then you can do your 9s and 3s. 3 goes into 3 once, 3 goes into 9 3 times. Now if I multiply across, I get 3 over 2. And then mixed fraction would be 1 and 1/2. Now, people ask me all the time, do I need to change to a mixed fraction? It kind of depends on the teacher. Like Mr. K likes kids to keep it in improper fractions. I like to see mixed numbers. The reason is this, because let's say this is my improper fraction. What does that mean? Does that mean anything to anybody? To me, right, like I don't know what that is. To me, if I at least change it to a mixed number, what is it? It's 5. Is that like a little more sense? Like I feel like having a whole number to me makes it a little more understandable. Yep. 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 Same rules. Yep. Same rules. So that's why I prefer mixed numbers, is because to me this means a little more than this. That's just me though. So, you guys have any questions so far? All right, let's try one. You try one. I'm going to give you one more. Ready? Let's do -2 and 1/4 divided by, and I don't know what kind of reducing is going to happen here, 1/3. There you go. 2 1/4 divided by 1/3. And probably isn't going to turn out great. Just saying. Remember, improper fraction first. Does it turn out like okay? Can you reduce it? Probably not. Darn it. Oh, it's not so bad. That's not so bad. Okay, anybody want to share? First of all, let's go through the steps. What did you do? Tell me what improper fraction you used. Go ahead. Okay. Okay. And then you probably flipped it right away. Okay, so then you got -27/4, which turns into what? 6 3/4 negative? Let's see, 24, 25, yeah, that's right, 26, 27, that's right. Good job. Any questions on how to do these? Kale, what's up?
So you can't reduce the 9.
And the 3? No, you have to flip first. You have to flip them first.
So it can't be
Correct. You can only reduce this way or up and down. You can't reduce from side to side. Okay? I'm glad you did that, though, so I can talk about it. Yeah, I'm glad you did that, because sometimes I need to talk about that stuff. So that's all right. Last thing I want to show, and this is actually in your homework today. Remember the other day I showed you multiplying algebraic fractions? Well, today we're dividing algebraic fractions. This is actually part of your homework today, though, okay? So that's why I kind of showed you the other day, to get you in the hang of this. So remember, algebraic fractions have a variable, possibly some variables inside, okay? So our job is to simplify it or divide it as much as we can do that. Here's the one we're working with. 5/3AB divided by 15/ABC. I feel like I'm saying my ABCs up here. All right, so same thing goes. Keep, change, flip. Okay, so we're going to keep the first, change the middle, flip the second one. 5/3AB times ABC/15. What are some things I can reduce off the bat? What are some things I can reduce off the bat, Kale? Sure. What can go in both? 5. Yep. 5 goes into 5 once. 5 goes into 15 3 times. Good job. What else can I reduce right off the bat up here? Bella? Sure. A and an A and a B and a B, right? Anything else I can reduce up here? No, I don't think so. I can't reduce anything else. Now, this is kind of the hard part, because we have a lot of things crossed off up here. So let's just go through the top line. What do we have left over? 1 and a C. Now, you could write 1 and a C or just C. I don't care what you do. If you want to write that, that's fine. If you just want to write a C, great. What do I have left on the bottom? 9, 3, and a 3. So that's what it looks like. That's what it would look like. Yep, that's the answer. That's as far as I can go. Ella. Okay. Kara? Nope. Nope, they're just going to make you simplify it as far as you can go. Okay, Haley? You can't what? Yes, so they're going to have to like here, and that's as far as you can go. Like you can't finish it. It's not going to tell you what A, B, and C are. It's just going to say this is as far as you can go. Okay, Bella? Not for this. Let's just quick, before we get done, let's do one more. Okay, so everybody's on the same page. Let's do this one. 5AB over 6 divided by 10B over 7. So this is how it would look. Times 7 over 10B. What can I reduce up here? What do you think? Bella? B and a B. 10 and 5. 5 goes into 5 once. 5 goes into 10 two times. Okay? Can't reduce anything else. There's no A's or 7 and 6. Can't do anything there. Yep. Sure. Correct. They have to be across from each other. They have to be across from each other. So let's see, what do I have left here? I have a 1, and I have an A and a 7. So really this would be 7A. And then the bottom I have just a 6 and a 2, right? So it'd be 12. Yep, the end. But yeah, same thing goes. You can only do if they're crossways. You can't do if they're... Okay? Any other questions? That's it. The end.